Good morning. My name is Eric. I'm one of the co-founders of Zentral. Short summary for those who don't know Zentral. Zentral is Apple MDM. And on the Mac platform, we integrate with OS Query for more visibility, better inventory. We integrate for Monkey for patch management. And we integrate also with Santa, which is a system security extension to do allow block list, to do file access controls and stuff like that. So today we are going to talk about I'm going to show you like some use cases we had recently with the customers we onboarded in the last year. So we start where it starts for us, where the journey starts for us. So last October, CPE contacted us, and they had a challenge. They had to be compliant. The UK devices had to be compliant by end of March. Compliant with CyberEssentials for the UK. So we ran the POV, and we had success. So the goals were achieved. But then we had to convince the management team and the decision makers to go with us. It's an international company, so we knew it would take a long time. So first meeting we had with them was last January. And remember, it was still like mid-March. And then, so by this time, I was nearly sure someone would pull the plug, because I was like, there's no way someone will approve that. But we said, like, in the case they approved, we started working ahead of time before the contracts were signed. And finally, they were signed. It was, mid-February. So we basically had 3 weeks to do the whole thing. So let's see how we did it. So I think that started could have been like a walk across the field, but no, it was a bit difficult. And of course, they wanted the best. They wanted streamlined migrations. I mean, like as quick as possible, and with minimum disruption. So great, we had great help from the CPE guy. He was really experienced with the notifications and all the stuff. But we had to no wipe and in a few minutes if possible. They wanted it to be triggered by the users. They didn't want to force it at first to the users. It could be that it's in the morning and you have a Zoom call and you don't want to force a migration before a Zoom call. It had to be local time as well. Of course, we started with UK devices, but they also had their new devices soon. So it has to run. Don't propose the migration in the night, or 9 a.m. UTC is not 9 a.m. for everyone in the world. And they wanted good guidance, always the same thing. Inform your users, tell them ahead of time what is going to happen. And the process had to be a control process. So obviously, progressive rollout with so little time to test ahead of time. We really wanted to have first a few devices involved, and then more, and to be able to always adjust the cohorts. Daily refinements, again, with so less lead time, we had to be able to push a new version, adapt, tweak things, wait a little bit longer on some steps, stuff like that. And obviously, measure the success, or measure where you have problems, so good reporting, and we even basically pushed all the events in the Slack channel so that all the CPEs in the teams, they could see what was happening when. So the solution, a bit of a technical slide. Again, instead, we're doing patch management with Monkey. Monkey, well established. The thing we could do with Monkey is that we could unroll the devices before the migration. So even when they're still in the older MDM, legacy MDM, we could still point them, we could already point them to Zentral. So basically in 2 or 3 days, we had the 500 devices that were in scope. They were already pointing to Zentral, and they are receiving the software updates and the migration tools from Zentral. So this is... We deployed an AWS Lambda function to proxy the API calls. Remember, the migration was triggered from the devices, so you cannot simply from the server side and unroll the device. It had to be, the first signal has to come from the users, and you don't want the API keys everywhere, so you want a bit of a control. So it's a standard solution to have like a cloud function to proxy the calls to the legacy MDM and to the new one, to Zentral. And then, I mean, you can do it the way you want, but usually it's a Python script because Monkey ships with its own Python, so it's signed, so it's already there, so we can use Python. And Swift dialog for the comms. And a really flexible possibility to switch the buttons, make the buttons mandatory or not, the deferral possible or not, stuff like that. So this is the flow chart. Don't worry, I'm going to zoom in. But basically, this is the process. Cannot really show the video. It would have been a mess to edit out the name of the customer, and they are not ready to share it. But yeah. So let's say we start. Is it big enough? Yeah. So we start with a trigger. A trigger can be a timer, again with local time, or a self-service item. We check the availability of the tools. Who knows? It could be that we have the trigger but not the tools. We want to make sure that the migration tools are there. And then the green boxes are basically the API calls to the Lambda. So we check if Zentral has the DEP device. So basically if the device is assigned to Zentral in ABM, because otherwise we don't want to trigger and then don't catch the device. And then we go a bit further. We check the Jamf enrollment because again it has to recover from some failure. So if we already enroll from Jamf, then we can skip. And then this is the blue box here is a UI choice, so it's a Swift dialog. At first we allow the users to defer, but at one point we just force the migration on them after a few days because come on. You have to migrate and get somewhere. So then this is where it happens. We send the unenroll command to the device from Jamf, so via the API call, and we wait for Jamf to unenroll the device. It can take a while depending on the queue in Jamf and the network conditions and stuff like that. And only when it's unenrolled in Jamf, then we can do the enrollment. So basically it's a profiles renew command. Since macOS 14, like you have got a full login screen, you do the authentication with the IDP, and then it goes. So you enroll in Zentral, and just the last bit. We wait for a Zentral enrollment, wait for a critical configuration. You have EDR tools, network tools, they need configuration profiles, you need a certificate. The script makes sure that all these important bits are there. We restart some of the tools that need to be restarted. CrowdStrike, Falcon needed to be restarted to make sure that it was catching up quickly with the new configurations when everything is good at the end. So, so I always do the same. I always forget, sorry. So the results, the migrations, as I said, most of the time in less than 2 minutes. Really good user engagement, so if you do that, be careful. We always say like people defer or no. The first 90% of the people we first presented with migration, they just clicked on migrate. So don't underestimate the users. High success rate after a few adjustments. If you run a passwordless organization and then you ask for a password during the Okta authentication of the enrollment, you are going to have a high failure rate. So be sure to be consistent with it. And there's still the possibility in the Apple UI that pops up to do the migration later, which is not optimal because at the time we present the migration, the device is not enrolled anymore. So all your tools, basically the users can't work. And Apple says, yeah, but we will present it back, but it's 8 hours afterwards. So probably like on a normal work day, it's basically the day after. So that's why it's important to have a self-service because then the people can contact support and support can say to them, go to the self-service, activate the thing. And yeah, so management was happy, and they expanded the scope of the devices that they wanted to manage with Zentral, so we were happy. So but remember, so migration is just to bring the devices into Zentral, but the goal was not only to have a better MDM tool, but to also achieve the compliance. So it was the compliance with CyberEssentials. So there are many aspects. There's a lot of aspects that are well known, like uncontroversial, controversy. Yeah, you can argue. For example, they don't want admin. They don't want. You have to have. You have to patch all the. If you read the specs, you have to patch all the apps on all the devices. It's nearly impossible to do it. It's something you have to do only if you are in public sector or if you have a contract with the public sector in the UK. But there are some other security baselines that are similar requirements. So the first thing that was important. I'm only going to talk about I'm not going to talk about admin, temporary admin access or stuff like that. This is in the different room. So we are going to talk about the app management. So the customer, talking with their SEC team and GRC team, they decided to focus on the browsers. And they decided to support 5 browsers or 6 and block the other ones. And they also decided to block the ones with known CVEs or known vulnerabilities. And they wanted to be able to point the users to the ones that were supported, or point the users to their self-service to run the updates so that they could run the updated version of a browser. The solution. Again, we patch with Monkey. Monkey is really the best tool, in our opinion, to patch third-party software. We use Santa to block the older version, Santa System Extension. I don't know how many people are familiar with Santa. A lot, not many. So it's a system extension, so it uses exactly the same framework like all the security tools. They get the event, and you can decide on the event. So you write a rule to say, I'm allowing this binary signed by this team to run, or I'm blocking this binary signed by this certificate. Thing is that it's signature-based, so it's secure, and it's basically the only thing that makes sense. So they were blocking the unsupported browsers and the browsers that were with CVEs. And Zentral, one of the key elements is that we collect a lot of events, we generate events, we put it in an event pipeline, and we build metrics based on these events. And we ship a Grafana instance in all the for all the Zentral tenants we deploy. So we were doing the reporting with Grafana. So the results, they were really happy. After the first week, they had like 98% of the devices that were compliant with their definition of CyberEssentials. It's not like all the software everywhere. It's their scope. This is a kind of graphs. So it's not the graphs they had, because you see it's not 98%, but it's a similar graph with about 1,000 devices, and we are patching Firefox. So it's classic burnout charts, and you can see like progressive deployment. So first a bit of a fit, and then at one point the CPE flips the switch, and then it's all. And everything like this portion and this is by choice, and it's not like random. So effective patching, the reporting is, you have the same kind of reporting, like you have basically this is a drop down, so you just pick the package. You can give read access only to these things to the users. The rules, we're talking about the rules. We manage all the configuration, the day-to-day configuration in Zentral via GitOps. It's possible. I mean, you can use the GUI, but you can run GitOps. So here is an example. So we have our Terraform provider. Terraform is a way to describe configuration or infrastructure as code. but it's also a way to apply it, to plan for what is going to change, get what is going to change ahead of time, and then apply it. And since it's a well-established standard, there are integrations with most of the CI/CD systems out of the box. So here you can see it's defining a resource. So it's our own resource, Central role, and you give it a name. So it's a reference to know if it's a new resource or an update. Here you can see like, I'm saying like Opera is not supported. So this is a custom message we can show in the popover, but it's configured in Terraform. Here you can see the type of policy, so we are blocking. And here you can see what we are blocking. And actually, you don't have to do too much details if you are blocking Opera, because you just block the team ID from the Opera organization. So everything that is signed by Opera, you just say like, you don't run it. Here is the standard GitHub integrations. You can see that Henry approved my change, that the checks were passed. So it means like we had the plan. Actually, the slide before was the output of a plan. That one thing is going to change. And since we have like a confirmation, we have a review, and the checks have passed, I can squash and merge. And the next time I deploy, instead of having only Terraform plan in the PR, I can do an apply. I mean, it's not I can do, the apply will open. And that's it. User guidance. This is what we've seen. So another version of a message. Here so this is what the popover that shows up when you run something that is not allowed. And then you can have a message, and you can even configure this. And the open button here, in that case, the CP configured it to open the self-service app. So that was it. So this is how we did CyberEssentials. Let me check the time. Oh yeah. So now I'm going to talk to you about another customer. So if you flip the thing, instead of blocking the stuff you don't want, you only allow the stuff you want. Because like we have another customer, AI industry, and they really want to protect their IP. They really don't want to run whatever software. They want to know exactly what is running on why. So in this case, you flip the switch. You turn Santa not in monitor mode, in lockdown mode. And you can have user-bound exceptions via Zentral, because we can distribute certain rules to certain people. I'm going to do a quick demo. Let me check how it works. Yeah. So I'm trying to run Super Collider. And you can see that there's a pop-up. I cannot run Super Collider. But there's a button here saying like request exception. I click on it. I'm brought to my IDP and then redirected to a user portal on Zentral. You can see that I'm authenticated, my device is recognized, I have some information about the thing, and I can vote for it. And now this thing has started at 0 point blocks. It has 25 points, it's a lot. It's a quick demo. Of course, you can give less power to your users. You can even give them 0, so that you only get the signal and you're not moving the needle, stuff like that. You can run the sync. You have to wait for Santa to sync, or you can run the sync manually. Here I'm going to run it like this, syncing the rules. They are working on a push thing, but it was specific to Google, so we have to wait for it to be not Google specific. So it's downloading, I hope it works. It's installing, it's a bit slow. And now I should be able to run Super Collider. Yeah, that's it. Another thing, so it's a vote. I'm going to skip the whole admin console. You can see in the admin console the votes. You can change the votes. You can reset the status of a thing to block it again. Admins have more power than other people. You can define it with IDP groups. If you want more details, just come talk to us. There is one more thing, just to illustrate. Santa can also do file access control. And here I'm in the, can you see it? I'm in the cookie, I'm in the profile of my Google Chrome profile. I'm so I should be able to access the cookies, they are read-write. But if I cat the cookie file, I cannot cat it. So basically, same kind of things. The signature of cat was not, the cat with its signature was not able to read the cookie files. And only the stuff signed by Google, and actually only Chrome, the way we configured it, only Chrome can read the cookie file. So it's like you drastically reduce the possibilities of stealing the cookies. So that's it. Last thing, let me check the time. Should be okay, I guess. We have compliance monitoring. So another customer, it was a neobank, wanted to know a little bit more about the compliance of their devices, and we talked to 3 different teams in that case. So there was like the IT team, they wanted inventory reports. There was a GRC team, they wanted to know like if the fleet was CIS. They wanted to know if we could prove the CIS compliance with their baseline, and there was a security team. They owned Falcon City, Falcon, and Zscaler, and they wanted to have like reports about like if Falcon or Zscaler was running properly. So demo quickly. How much time do I have left? About 10 minutes, I guess. Huh? So I'm going to show the, what is it? Safari? Yeah. So this is the inventory in Zentral. You can see that we combine the tools we're talking about, and they all contribute to a single inventory. So you have a unified inventory. You can also plug in some extra sources. We are working on Google Workspace to get the Chromebooks in there and stuff like that. So I'm going to pick, so I have to authenticate again. I'm going to pick a device. I'm going to pick my device. And so you can see like the multiple tabs, but all the fields are nearly identical. It's just like some tools like OSQuery can report way more information than the MDM. Monkey is also very precise. If we have the apps can be reported by these tools, but you can see that the MDM has less information than OSQuery. That's why we try to combine those tools to get like the better visibility. And we have really precise information about what is installed. So that's the first steps, getting inventory, and everything can be extracted via API. Then we have the first compliance checks. So very simple compliance checks. We check if OSQuery is installed. And here you can see, let's think of the inventory data that you showed in the GUI as a tree, and we are checking in that tree if we can see a bundle on disk that is OSQuery. So this is really like without, I would say like, even if you have a third-party inventory source that is without agents, we can still run compliance checks in Zentral. So that's first level of compliance checks. Second level of compliance checks we have is the full MSCP integration. So Max Security Compliance Project integration, and we've got scripts, and we run them using Monkey. So if you're probably familiar with this kind of scripts, we check the results. And again, it's another kind of compliance checks, but for Zentral it's still a compliance check. So they all contribute to the same health of the device. And for OSQuery, we also can run OSQuery compliance checks. We have, for example, to illustrate the differences, this check uses a standard table and makes sure that the system security extension is loaded and active and has a minimum version. Very important to use like the version compare. It's really great because you don't have to split the strings and compare it. It's already built in OSQuery, very important. So this stuff is vanilla, but if you run your own extensions, then you can do extra stuff. For example, here we have an extension, it's open source. We run Falcon CTL within OSQuery, and then we can report on it as if we were running Falcon CTL. And then it ends up in the same event stream and matrix and everything. So I haven't talking about that because if we go back to the machine, we can see so all the compliance checks, and even if they are different kinds, they all contribute to the same. and then we produce. So we have like an absolute table with, like, for example, 7 days. So it would be like the compliance of a whole fleet. So we have test devices here a bit. It would be like all the compliance checks on all the devices. And then you can run like graphs of one single compliance checks across time. So it's boring because it's all compliant, but you see like red and green. We check again. Yep. So that's about it. Yeah. So you've seen the inventory, the compliance checks, stuff like that. So let's go back to the demo, to a slide. So yeah, basically, you've seen that we have all the compliance and the inventory information. But what we've done with the demo, except like, yeah, of course we have the events, we can ship them to a CM. But what we have done is that we have only looked at it. We've looked at it via the reports, even if it's the API reports or the dashboards. We haven't really done something with it. And so obviously one of the use case for this kind of data is conditional access. You all know what it is. You combine the health of the device with the status of a user to give or block access to apps that are mostly online or via kind of a network protocol. And we were reminded by a customer that there was something to give this status to providers. Because like if you think of Okta or Cloudflare or network providers or IDP providers, they all have their kind of way of getting the status of a device, but it's all like, it's never as precise as what we can do. And they all run their little compliance, and it's hard for us to contribute to that, except that now there is like a standard, the shared signal frameworks. To make zero trust work, we have to talk to each other. That's really what we think is the case. We don't want, it's not supposed to be a product that you buy and you have everything. It's supposed to be like an IDP, a network solution, and some compliance tools, and they share information, and you can build your policies and achieve really a real good zero trust solution. So it's a new standard from the OpenID Foundation, so there's a good chance it's established, and it has already been implemented by Jamf, by the way. So it's a well-established standard, and it's really about sharing security events. So you might be familiar with it, because if you want to have your own IDP in ABM, in the Apple Business Manager, your IDP has to support shared signals, like has to communicate the end of a user session, for example. So it's very simple. It's Zentral sending some security events to Okta. So we have the security events. So this is the event log for each device in Zentral as an event log. We have everything, Monkey, MDM, and everything. So we have one kind of event that is like when the total compliance status of a machine changed. So here we failed. This is how the events look like in if you ship it to your CM, or if you look in the details in Zentral. You see like the payload, failed to, OK to failed. As you can see that we put like a lot of inventory data in the event as well, so that when your guys run detections in the CMs, they don't have to do lookup tables. They can use directly this data. And here is a translation in shared signal thing. So it's a JSON web token. This thing is signed. You've got the standard event here, and it's basically a translation of the event before and the subject. Here, there's a very big star problem, potentially. I still have an open ticket via Okta because they haven't given me the real format and ID that they use. It's been 7 days. Some people think that big vendors can give them better support, but I'm not convinced. So yeah, it's something that should look like that. I was able to link a token to a user, but I was not able to link it to a device because the docs are not matching what Okta is expecting, but we'll see. But it should look like that. I mean, the stuff before, it was definitely this. It's definitely this kind of event, and this is format. And yeah, just to show, like in maybe you are familiar with this. There's security logs in Okta. So yeah, like it's definitely like one event that we managed to translate, but we managed to attach it to a user, not to a device, but it's coming. And it's basically an event translated in this framework in the security logs in Okta. So then it's attached to the device or the user, and then you can use your policies to do conditional access. So that's about it. So yeah, we really believe that as much as people want to dominate all the whole IT market, we really believe that there are tools that are better for doing some stuff, and the collaboration via standards is really key. It allows us to participate instead of an API that is private and only available via a contract. We can actually talk standards between each of us. And your MDM knows the compliance of your device, we think, better than Okta. And it's an image that is from the talk that Henry gave last year, here on this stage. And you can see like Okta Verify trying to be like somehow confused, like one update, but the versions are the same. And even if it's confused because it's like 3.1 and there's 4.1, but actually like at the same time in system settings, there's already like 14.5. So yeah, I mean, they probably fixed it, but the MDM has better information. That's it. Please, if you have more questions, we can take some of them now. I think we have 8 minutes left or 5, I don't know exactly. And if not, for more detailed stuff or demo stuff, we are still for a few hours, maybe 2, downstairs. Thank you.
But I mean, so in terms of the shared signal stuff, so you're looking at then preventing sign-in for devices that don't meet posture.
Yeah.
But using shared signals framework rather than plugging in like an IDP factor, like a Collide product might do. So it's a different way of achieving that sort of thing. If I'm understanding correctly.
So instead of getting the device health from Cloudflare Warp, nicht Wrap, apparently I'm hungry, or Okta Verify, because they all have their kind of mechanisms. Instead of doing that, you get the change of compliance from it could be an MDM, it could be something else.
Okay.
It's a new standard.
Yeah, no, okay, but understand. Okay.
Obviously, you need like a self-service possibility to rerun the scans so that you can transmit like you want the users to be able to unlock themselves and don't have to wait like 4 hours before their device is compliant and then they can log in again. So I'm not saying like it's a complete solution, but it's...
Okay, but so the idea is then if the device is out of compliance, using shared signals to tell Okta don't let this person in until they fix the fact they're out of compliance.
Yeah.
Which is what Collide does, but you're doing it in a different way using shared signals.
Yeah, they don't use shared signals.
Because they're using OS query and stuff.
Yeah, we use OS query as well. No, what they do is that they do it was a sad state of affairs before that. They would do an extra SAML run, SAML authentication. So that's why in Okta you can configure a second SAML provider. So you do the first SAML run with Okta, then Okta sends you to Collide. Collide doesn't do really SAML, it does like a device check. The browser is talking locally to the Collide daemon over 127.0.0.1 to get the device check. It's kind of sketchy with a browser, and then the SAML session goes back to Okta, and then Okta goes back to and gives you the SAML claims gives the SAML claims to the app. And we think it's a sad state of affair because then you are in the loop of every login. And we don't want that. We just want to transmit the signals, and then Okta can do the decision without redirecting, asking locally, and do all that stuff.
I'll come and talk to you about that later. Cool, thank you.
What MDMs currently support SSL?
I think Jamf, that's about it. And us, as soon as the ticket is closed. Hopefully. We're attacking at every angle. That's it. Thank you very much.